Hello everyone, welcome back to the channel from Cryptowichard. In today's video, we're going to take a closer look at the Internet Computer ICP, a new blockchain-based project that aims to revolutionize the way we think about decentralized computing. In the past, blockchain technology has been associated with cryptocurrencies such as Bitcoin and Ethereum. However, the Internet Computer ICP is different. It is a new blockchain network that is focused on creating a decentralized computing platform that can run web applications and smart contracts. But before we dive in, make sure you subscribe to our channel and hit the notification bell to get updates every time we upload a new video. So, grab a cup of coffee, let's dive into the world of Internet Computer ICP and explore what it has to offer. Understanding Internet Computer ICP. At its core, a blockchain is a decentralized database that stores information across a network of computers. Each computer on the network, known as a node, maintains a copy of the database and works together with other nodes to validate and record new transactions. When a new transaction is initiated on the blockchain, it is verified by the nodes on the network. Once the transaction has been verified, it is added to a block of other validated transactions. Each block is then linked to the previous block, creating a chain of blocks that makes up the blockchain. One of the key advantages of using a blockchain is that it provides a high degree of security and transparency. Because the data on the blockchain is distributed across a network of nodes, there is no single point of failure. This makes it extremely difficult for hackers to tamper with or steal data on the blockchain. In addition to providing security, blockchains also offer transparency. Because the data on the blockchain is public, anyone can access and view it. This makes it ideal for applications such as supply chain management, where it is important to track the movement of goods and verify their authenticity. Blockchains are also immutable, meaning that once a block has been added to the chain, it cannot be altered or deleted. This provides an additional layer of security and helps to ensure the integrity of the data on the blockchain. In summary, blockchains are a powerful technology that provide a secure and transparent way to store and manage data. By using a distributed network of nodes to validate and record transactions, blockchains offer a level of security and transparency that is unmatched by traditional centralized databases. The Internet Computer ICP builds on the concept of a blockchain to create a new type of decentralized computing platform. Rather than simply storing and managing data on the blockchain, the Internet Computer allows developers to build and run web applications and smart contracts on a decentralized network. Traditionally, web applications and smart contracts are hosted on centralized servers that are owned and operated by a single entity. This creates a number of challenges, including issues with scalability, security, and control. The Internet Computer ICP solves these problems by creating a decentralized network of nodes that work together to host and run applications. By using the Internet Computer ICP, developers can create and deploy web applications and smart contracts that are truly decentralized. This means that they are not hosted on a single server, but rather are distributed across the network of nodes that make up the Internet Computer. This provides a number of advantages, including increased scalability, improved security, and greater control over the applications. In addition to providing a decentralized platform for building and running web applications, the Internet Computer ICP also uses a new type of blockchain technology called chain key technology that allows for extremely fast and efficient processing of transactions. This makes it possible to build and run complex applications that require a high degree of processing power, without the need for centralized servers. The Internet Computer ICP represents a major breakthrough in the field of decentralized computing. By allowing developers to build and run web applications and smart contracts on a truly decentralized platform, the Internet Computer ICP is helping to create a more secure, transparent, and efficient Internet for everyone. One of the most unique features of the Internet Computer ICP is its ability to run code directly on the blockchain. This is made possible by a new type of programming language called Motoko, which is specifically designed to work with the Internet Computer. When developers write code in Motoko, they can deploy it directly onto the Internet Computer blockchain, rather than relying on third-party servers to host and run their applications. This allows for a truly decentralized computing platform that is not reliant on any central authorities or intermediaries. The ability to run code directly on the blockchain has a number of benefits. For one, it increases the security of the application by removing the need for a centralized server that could be vulnerable to attacks or hacks. It also improves the efficiency of the application, as there is no need for data to be constantly transferred back and forth between the server and the user's device. In addition, running code directly on the blockchain allows for greater transparency and accountability. Because all transactions are recorded on the blockchain, it is easy to audit and verify the behavior of the application, ensuring that it is operating as intended. The ability to run code directly on the blockchain is a major step forward in the field of decentralized computing. By removing the need for centralized servers, the Internet Computer ICP is helping to create a more secure, efficient, and transparent Internet for everyone. The governance model of the Internet Computer ICP is another key feature that sets it apart from other blockchain and decentralized computing platforms. Rather than being controlled by a central authority or a small group of developers, the network is governed by a decentralized community of node operators, developers, and token holders. This community-based governance model ensures that decisions about the future of the network are made in a transparent and democratic manner. Anyone can participate in the governance process by holding ICP tokens, which give them the right to vote on proposals and changes to the network. In addition to providing a more democratic and transparent governance model, the Internet Computer ICP's community-based approach also helps to ensure the long-term sustainability of the network. Because decisions are made by the community as a whole, rather than by a single entity, there is less risk of the network being taken over or controlled by outside forces. To further strengthen the governance model, the Internet Computer ICP also uses a system of neurons to allow token holders to lock up their tokens for a certain period of time and participate in the decision-making process. This helps to ensure that decisions are made by token holders who are committed to the long-term success of the network, rather than by those who are only interested in short-term gains. The community-based governance model of the Internet Computer ICP is an important innovation in the field of decentralized computing. By giving the community a say in the future of the network, the Internet Computer ICP is helping to create a more democratic, transparent, and sustainable Internet for everyone. The Internet Computer ICP offers several benefits over traditional centralized computing platforms. Here are a few of the most important. Security is another important feature of the Internet Computer ICP. Because the network is decentralized, it is much more secure than traditional computing platforms. This is because there is no single point of failure that hackers can target in order to take down the network. In a traditional computing platform, there is usually a central server or a small group of servers that control access to the data and applications. If a hacker is able to gain access to these servers, they can potentially gain access to all of the data and applications on the platform. With the Internet Computer ICP, however, there is no central server or group of servers. Instead, the network is distributed across a large number of nodes, which are run by individual users and organizations. Each node is responsible for processing transactions and storing a copy of the blockchain, which means that there is no single point of failure that can be targeted by hackers. Furthermore, the Internet Computer ICP uses advanced cryptography and other security measures to ensure that transactions are secure and tamper-proof. For example, all transactions on the network are validated using a consensus mechanism called threshold relay, which ensures that all nodes on the network agree on the state of the blockchain. Overall, the security of the Internet Computer ICP is a major advantage over traditional computing platforms. By eliminating central points of failure and using advanced security measures, the network is much more resistant to attacks and hacks, making it a more secure platform for building and running decentralized applications. Cost-effectiveness is another important feature of the Internet Computer ICP. Running applications on the network is much more cost-effective than running them on traditional centralized servers. This is because the network is maintained by a community of node operators, rather than a centralized entity. In a traditional computing platform, running applications can be very expensive, as users have to pay for the hardware, software, and maintenance costs associated with running the servers. These costs can quickly add up, especially for high-traffic applications. With the Internet Computer ICP, however, the network is maintained by a community of node operators who are incentivized to keep the network running smoothly. These node operators are rewarded with ICP tokens for their work, which helps to ensure that the network remains stable and secure. Because the cost of running the network is distributed among the node operators, rather than being borne by a centralized entity, the cost of running applications on the Internet Computer ICP is much lower than on traditional centralized servers. This makes it a more cost-effective platform for developers who are looking to build and run decentralized applications. The cost-effectiveness of the Internet Computer ICP is an important advantage over traditional centralized servers. By distributing the costs of running the network among a community of node operators, the network is able to provide a more cost-effective platform for building and running decentralized applications. Scalability is another important feature of the Internet Computer ICP. The network is designed to be highly scalable, which means that it can handle a large number of transactions and applications simultaneously, making it ideal for businesses and organizations of all sizes. Scalability is a critical factor in the success of any computing platform. As more users and applications are added to the network, the platform must be able to handle the increased demand without slowing down or becoming overwhelmed. With the Internet Computer ICP, scalability is achieved through a number of different mechanisms. For example, the network uses a sharding mechanism to divide the workload among different nodes, which helps to distribute the processing load and prevent any one node from becoming overwhelmed. The network also uses a unique consensus mechanism called threshold relay, which allows the network to process a large number of transactions simultaneously, while maintaining security and reliability. The scalability of the Internet Computer ICP is a major advantage over other computing platforms. By providing a highly scalable platform that can handle a large number of transactions and applications simultaneously, the network is able to meet the needs of businesses and organizations of all sizes, from small startups to large enterprises. Use cases for Internet Computer ICP. The Internet Computer ICP has several use cases, including: another important feature of the Internet Computer ICP is its ability to support decentralized finance, DeFi, applications. DeFi is a rapidly growing area of the blockchain ecosystem that allows users to borrow, lend, and trade cryptocurrencies without relying on centralized exchanges. One of the key advantages of DeFi is that it eliminates the need for intermediaries, such as banks or other financial institutions. Instead, users can interact directly with the blockchain, using smart contracts to facilitate transactions and manage their assets. With the Internet Computer ICP, developers can create DeFi applications that take advantage of the platform's decentralized nature. By running code directly on the blockchain, these applications can be fully decentralized, with no single point of failure or control. This makes it possible for users to trade, lend, and borrow cryptocurrencies without relying on centralized exchanges or financial institutions. Instead, they can interact directly with the blockchain, using smart contracts to manage their transactions and assets. The ability to support DeFi applications is an important advantage of the Internet Computer ICP. By providing a decentralized platform that allows developers to create these applications, the network is able to offer users a more secure, transparent, and efficient way to manage their finances on the blockchain. The Internet Computer ICP can also be used to create decentralized social media platforms that protect users' privacy and data. Social media has become a ubiquitous part of modern life, but traditional social media platforms have been criticized for their handling of user data and privacy. Decentralized social media platforms built on the Internet Computer ICP offer an alternative. By running on a decentralized network, these platforms can provide users with greater control over their data and privacy. They can also offer greater transparency and accountability, as the underlying code is open source and auditable. Moreover, decentralized social media platforms built on the Internet Computer ICP can provide users with more control over the content they see and share. For example, users can curate their own content feeds based on their interests and preferences, without being subjected to algorithmic manipulation or corporate influence. The ability to support decentralized social media platforms is another important advantage of the Internet Computer ICP. By providing a decentralized platform that allows developers to create these applications, the network is able to offer users a more secure, transparent, and user-centric way to engage with social media. The Internet Computer ICP can also be used to create decentralized gaming platforms that allow users to play games without relying on centralized servers. Gaming is a popular and rapidly growing industry, but traditional gaming platforms have been criticized for their reliance on centralized servers and closed ecosystems. Decentralized gaming platforms built on the Internet Computer ICP offer an alternative. By running on a decentralized network, these platforms can provide users with greater control over their gaming experiences. They can also offer greater transparency and fairness, as the underlying code is open source and auditable. Moreover, decentralized gaming platforms built on the Internet Computer ICP can provide users with more opportunities for collaboration and community building. For example, users can team up with other players from around the world to complete challenges and quests, without being subjected to geographic restrictions or corporate limitations. The ability to support decentralized gaming platforms is another important advantage of the Internet Computer ICP. By providing a decentralized platform that allows developers to create these applications, the network is able to offer users a more secure, transparent, and collaborative way to engage with gaming. Criticisms of Internet Computer ICP. As with any new technology, the Internet Computer ICP has faced criticism from some quarters. Some of the main criticisms include: some critics have argued that the Internet Computer ICP is still too centralized despite its claims of being decentralized. This is because the network is controlled by a relatively small group of node operators and token holders. While the governance model of the Internet Computer ICP is designed to be decentralized, it is true that a small group of node operators and token holders currently hold a significant amount of power within the network. This has led to concerns that the network may be vulnerable to centralization and potentially subject to the influence of powerful stakeholders. However, it is worth noting that the Internet Computer ICP is still a relatively young network and is actively working to address these concerns. The network has implemented various mechanisms to ensure that power is distributed more evenly among its participants, such as its neuron voting system and governance token economics. Moreover, the Internet Computer ICP is committed to ongoing development and improvement, and is working to foster a more diverse and inclusive community of participants. By continuing to engage with its users and address concerns around centralization, the network has the potential to become even more decentralized and resilient over time. It is true that the Internet Computer ICP is a complex platform that requires a high level of technical expertise to use effectively. This complexity may limit its appeal to non-technical users who may find it difficult to navigate and use the platform. The Internet Computer ICP is designed to be a powerful and flexible platform that can support a wide range of applications and use cases. However, this flexibility comes at a cost in terms of complexity. Developers who wish to build applications on the Internet Computer ICP must have a deep understanding of blockchain technology, smart contract programming, and other related technical areas. While this may be a challenge for some users, it is worth noting that the Internet Computer ICP is actively working to address this issue. The network provides a range of resources and documentation to help developers get started, including tutorials, code examples, and community support forums. Moreover, the Internet Computer ICP is actively working to improve the user experience and make the platform more accessible to non-technical users. For example, the network is developing user-friendly interfaces and tools that can simplify the process of building and deploying applications on the platform. While the complexity of the Internet Computer ICP may limit its appeal to some users, the network is actively working to address these challenges and make the platform more accessible to a wider range of users over time. Thank you for watching, and I hope you found this video informative. If you have any questions or comments, please leave them below. Don't forget to subscribe to my channel for more trading videos and hit the bell icon to be notified when I upload new content.